Section 7.3, the ambiguous case. In the previous two sections, we introduced two major things. One is called the law of sines, and the other one is the law of cosines. And those two things, I look at them as tools to help us to solve for the triangles. And what do we mean by solve for triangles? Means they help us to find all the missing sides and angles in a given triangle. And why does that matter for us in real life situations? Because as you could see some examples in the previous sections about let's say you want to find the height of the building, or you want to find the distance between 2 points, but the shape you have, you can reach to these 2 points, or not easy to access those 2 points to be able to measure the distance between them. But you can, if you form a triangle around a given region that you can reach, probably if you are able to find one of the angles on 2 sides, or 2 sides and 1 angle, then probably you can find the third side that you're looking for. So there's so many applications to the law of sines and law of cosines in real life situations. And what we did, just in summary, very quick, we had when we had the AAS case, so they give you 2 angles and not included side, or angle side angle, like 2 angles with the included side. In these 2 cases, we use the law of sines. So we can use law of sines to solve for the triangle, no matter how what kind of case, but we can still solve for the triangle. The other one was the SSS. Here we can't use law of sines, not enough, so we use law of cosines to solve for the triangle. And the next case is the SSA case. This case is a challenging case, I call it. So this is the ambiguous case called. This is the ambiguous case. So in this case, we're going to be doing a lot of work on this. So the ambiguous case, in the ambiguous case, there are several possibilities. We're going to be working with several possibilities. So I'm going to go over them. There are actually, they're going to be 4 cases we're going to be working on later. But for the meantime, let's start. Suppose we have an acute angle. Suppose alpha is an angle between 0 and 90 degrees. It's an acute angle. And sides A and B. So sides A and B are given. In general, just to recall before all of this, if you have any triangle ABC, the side facing A, angle A, it has a length small a, B has small b, C small c. And A is alpha, B is beta, and C gamma. That's these are the Greek letters, alpha, beta, gamma. So what we need to do first, when one angle is given and 2 sides, first thing always, you're going to construct that given angle. So I'm going to start, this is called the initial side of the angle, say angle alpha. So this is the initial side, this is angle alpha, so A. And this is called the terminal side of angle alpha. Say this is B. So B, this means that this point here, possibly, that's going to be capital B, and we already have C and A in there, so then we expect this to be the C. So the first thing, you draw this. That's the first step. Draw the given. In that sense, plot the given this way. But don't draw the third side yet. But no A yet. So it means don't construct A yet. What we do instead, we drop a height from that point down on this side AB. Call it small h. So we drop a height all the time. So this is the H will be the distance from C to the initial side of alpha. And watch what I'm going to do. I'm going to find sine alpha by SOHCAHTOA, opposite over the hypotenuse. So from here we can find that H by cross multiplication is B times sine alpha. Okay, keep this in mind. I'm going to have to use this all the time. Now, after we do this, we draw the side A. But after the drawing, there are 4 possibilities. There are 4 possibilities for its location. Where is side A gonna be? What is side A gonna be? So we're gonna take all these cases one at a time and then use those cases to help us go through the entire section. What is the first case? So I'm gonna choose the first case. First thing, if A means the length of side is less than the length of H, then what happens in this case? Watch, I'm gonna redraw the figure A, alpha, B, C here. This is the height that we drew. And assume A is less than H, so A can be something like this maybe. That's A less than H. So what does that mean? This means no triangle can be formed. In this case, if there's no triangle, we can't solve for it. So it's done. You just say no triangle. What about if A equals H? This is an easy case. If A equals H, if I want to draw this case as well, this is A alpha, this is B C. If A equals H, notice how we jump the height. A equals H, so this is going to be A. So in this case, we are going to having just this as a triangle. So then there is exactly one right triangle. And then from here, we know this angle is 90, alpha is given, I can find this angle there, B is given, I can find C, and A is given, so it's done. Then we will be able to finish solving for the triangle. Next one. If we calculate H, and then we found that H is less than A less than B, okay, then there are going to be 2 triangles. 2 triangles can be formed. Then there are 2 triangles. So what does that mean, 2 triangles? How is that going to be? Well, it's going to look like this. Let me draw this again. A, alpha, B. C is here. The height is down there. So the first one case is that it could come inside like this. This is B. See, if this is B, this is beta, this is gamma here. This would be A. Okay, this would be A. And this is, because the upper point is C, this is small c. So notice from this figure, notice how H is less than A, because A is slanted, right? A is slanted. So that's one possibility. Or the other possibility, it can be outside. So it can look like this. If we draw it again, this is H, C, this is B, then A could go outside, as you can see. A could be outside. So this is A. And this is B. This is B. In this case, this is beta, this is C, this is gamma, as you can see. Right? So this is alpha. So there are 2 cases. Notice also A is slanted on the right side, so it's longer than H. So this is the case that requires more work than other cases, because you have to solve for 2 different triangles in this case. 2 different triangles. And you might be wondering, how come I'm going to solve for 2 different triangles? We will see. While we're working with these cases, all these 4 cases, the law of sines will be used. And then students ask, can I use the law of cosines? We will see if we use law of cosines what also is going to happen. But 95% of the time, we're going to be focused on the law of sines and how to use law of sines in these 4 cases. The next case is the case when A is bigger than or equal to B. In this case, only one triangle is formed. Only one triangle is formed. And that's going to be like this: A, C, B, A. This is B, the height as we had it before, and all this is small c. Okay, so these are the 4 cases that we have. And again, we use law of sines to go over all these cases. We use the law of sines to go over all these cases. Now, in any of these cases we are working with, or in any question, if you're asked to solve for a triangle. Now, in the previous 2 sections, notice something. We went straight ahead and then we try, okay, let me use law of sines, or, oh, try law of sines, it doesn't work, let me use law of cosines. And then our goal was just to solve for the triangle. But if in case you are given this case, you are given this ambiguous case, you look at the given, oh, they give me 2 sides and none included angle. Then I have to think about the ambiguous case. This is the ambiguous case. We have to watch it. So the first thing we need to do before we start solving for the triangle, we must first determine the number of triangles. Number of triangles. That's the first thing we need to do before actually we can solve the triangle or triangles. That's very important. So let's look at examples. Let's look at some examples. Given, let's say given alpha, angle alpha is given 41 degrees. A has a length of 3.3, B has a length 5.4, and they ask us to solve the triangle. So solve the triangle. What they give us? A and B and angle alpha. So they give me 2 sides and none included angle. None included angle. So this is the first thing that I see SSA case. So that's the ambiguous case. So we have to be careful before we start going into law of sines, law of cosines. We need to find out how many triangles we have here. So figure is the first thing. So I'm going to draw the figure like so. This is A, this is alpha, which is 41 degrees. This is B, which is 5.4. This is C, and we're going to drop the height. This is the height. And first thing, if you look at the cases, so I'm assuming the cases are on front of you right now. You look at those 4 cases. The first thing we need to check, is A bigger than or equal to B? Is A bigger or equal to B? No. So that wipes off the 4th case. The 4th case said if A bigger or equal to B, then there's one triangle. So I don't have to worry about that one. After that, we need to find H now. So we defined H was B sine alpha. Okay, B sine alpha. So we're going to find H by substituting. B is 5.4. Sine alpha is 41 degrees. And then if you put that into the calculator, that gives us 3.54. Okay, 3.54. Now we're going to compare A and H. Is A less than H? Where is A? A was 3 point, so let me write A here, 3.3. Is A less than H? Yes, A less than H. Note that A, which is 3.3, is less than H. So from the 4 cases, this fits the first case, means no triangle can be formed. And the solution is done. We can't solve the triangle because there's no triangle in the first place. Now the next thing, I'm going to show another example, but this way I'm not going to give always A, B, and small a, or alpha, B, A. So I'm going to give it different ones. Another example, given gamma equals 125 degrees, B is 5.7, C is 8.6, and they want us to solve the triangle. solve the triangle. So how are we going to solve for the triangle? Well, let's see. The first thing is, you like to draw the triangle? You can do so, but let's see what happened. I have 125 degrees here. Gamma is 125. Okay, B is the 5.7. Gamma always at point C. And because this is B, the side facing that, which is the horizontal line, that's going to contain the point B somewhere. Let's say it's here. So this means the last one is A. So what is C? C is the line that goes from here to there, but we're not going to draw it for now. First thing we do is compare, if you remember the fourth case, A bigger than or equal to B. So what happened? I was comparing A, which in this case is C, right? AC. Is A bigger than or equal to B? In this case, is C bigger than or equal to B? Okay, so we need to check that out. And at the same time, we need to find the height. What is the height? The height, I'm sure each one of you can find the height. Again, before we find the height, let me step back. Before we find the height, we compared this side here, which is C always. In the previous example was A. Is C bigger than B or equal? If so, then there's one triangle. That would be the fourth case. Notice C, in this case 8.6. Is it bigger than B? Yes, it is bigger than B, which is 5.7. So this tells us there's only one triangle can be formed. Only one triangle can be formed. This means C can reach all the way to point B. C can reach all the way to point B. Now I'll start solving for the triangle because there's only one triangle. I'm gonna solve for it. Here we just try to find how many triangles are there. Is 0, 1, or 2. So in this case, we are given gamma and B, and also they give us C, which is 8.6. I need to find the rest. This is alpha, this is beta, and this is small a. So always we start with law of sine. So sine the given angle 125 degrees over 8.6 equals sine beta over 5.7, right? Equals sine alpha over a. But we don't know beta, so I can't find alpha yet. So this means I'm going to take these two, cross multiply 8.6 times sine beta equals 5.7 sine 125. And we're going to solve for sine beta. So sine beta equals 5.7 sine 125 degrees divided by 8.6. And how do I find beta? Beta is sine inverse of 5.7 sine of 125 degrees divided by 8.6. And what we can do, put that in the calculator. So beta will give us 32.9 degrees. So I found beta. Remember, 3 things are given, 3 are missing. So we found beta. Now we need to find alpha. Alpha is going to be 180 minus the sum of the other 2 angles. The given one and the one that we just found. If we subtract them from 180, that would give us 22.1 degrees. That's alpha. So I found 2 angles. Now I need to find A. How do I find A? So I can take first one with the last one. That's where A is. So sine 125 over 8.6 equals sine alpha. So sine, we found alpha, 22.1 degrees over A. Again, to solve for A, cross multiply. A times sine 125 equals 8.6 sine 22.1. Then you can divide both sides by sine 125. And what do we get here? Put that in the calculator. I got 3.9. So I found the 3 missing components of the triangle. 2 angles and 1 side. 2 angles and 1 side. Let's look at another example. Given, back to alpha. Alpha is 56.3 degrees. Let's make it in decimal. B is given 8.3. and A is 7.6. Solve the triangle. Always keep in mind, we need to find out how many triangles we have. And then after we find the number of triangles, we decide how to solve it if we have one or two triangles. So, as I said, always I ask, is A bigger than or equal to B? Is A bigger than or equal to B? And remember the figure would look like this, 56.3 degrees. This is B, 8.3. This is A. So is A bigger than B? Well, let's see. Is A bigger than B? No. The answer is no. So that case where when A bigger than or equal to B, we have one triangle is gone. Now we have to find H. H equals B sine alpha. This is H. You drop a height. Good to draw a diagram. B is 8.3. Sine alpha is 56.3 degrees. So then H, if you put that in the calculator, I got 6.9, about 6.9. So this is H, 6.9. Note that H is really bigger than A, bigger than B, or you can say B less than A, less than H. So then two triangles can be formed. Two triangles can be formed. Okay, so what are these triangles? We need to solve for them. So let's draw the diagram again. B was 8.3. This is C, and this was the height. Okay, so what do we have here? We have two cases. I'm gonna label the first one with green. That's B, that's beta, that's gamma. And this is small c, this is A. Okay, that's A. So what do we have here? We need to solve for this triangle. How do we solve this? Remember law of sines. So sine alpha was given 56.3 degrees divided by A, and A was 7.6 equals sine beta over 8.3. So from here, we're going to solve for beta, cross multiply. So 7.6 sine beta equals 8.3 sine 56.3 degrees. Then sine of beta is 8.3 sine of 56.3 degrees divided by 7.6. And then after we find this, then we can find what beta is. So beta is going to be sine inverse of 8.3 sine 56.3 over 7.6. Okay, one thing to keep in mind. Remember, A, B, and C are the angles of the triangle. So what we do here, we know that their sum is 180. So all the angles, alpha, beta, and gamma, they should be between 0 and 180. So this means we are working only in the first quadrant and the second quadrant. So the angles can be anywhere from 0 to 180. Okay, now if I put this on the calculator, that will give me 65.3 degrees. But guess what? There are two cases here. The first case is this. So this is the 65.3 degrees. And sine is positive also in the second quadrant, say somewhere here. So this is the 65.3. To find the next one, this one, it's always 180 minus the other one. So let's do it on the side. I'm going to call this beta 1. So beta 2 is 180 minus the angle that I just found. And then if we do the calculation, that gives us 114.7 degrees. So this goes, I'm going to go back to the green, label this with beta 1 on the figure, as you can see. That's beta 1. So remember, three things you need to find. Did I find anything yet? Well, I found beta, and they give me alpha. So then I can find gamma. Gamma would be 180 minus the sum of alpha, 56.3 plus 65.3. And if we subtract that out, that gives us Let's subtract them just to verify the answer. Minus 56.3 and minus 65.3. It's 58.4. So this equals 58.4 degrees. So I found two things. One more thing. What is missing? So I'm done with the angles. A is given, B given. I need to find C. So we continue with Law of Sines to find C. So I can say sine alpha, which is 56.3, over A was 7.6, equals sine gamma over C. We need C. So cross multiply. C sine 56.3 equals 7.6 sine 58.4. And C would be 7.6 sine 58.4 divided by sine 56.3. That's for C. And now we're gonna put this into the calculator to see what that is gonna give us. So if we put it on the calculator, C will be about 7.8. So I found the three things that are missing in this triangle. The three things that are missing in this triangle. Now that's the first case. The next one, I'm gonna go back to the figure and use the blue color. This is the other triangle. I'm gonna trace the whole thing. This is our B, that's beta 2. Now the new gamma would be the whole thing. Alpha stays the same. This is the new C. That's like total new triangle. This is A. A was given 7.6. Okay, 7.6. So now what we do is we're given A, B, and alpha. We just need to find C, gamma, and beta 2. So we actually found beta 2. So from here, we can find gamma right away. 180 minus. Alpha stays the same, but beta is 114.7. If we do the calculation, I got 9 degrees. So that's beta. I found two of the missing items. One more to go is to find C. We can do the same thing as we did on the left side. So sine 56.3 degrees divided by 7.6 equals sine gamma is 9 over C. Cross multiply. C times sine 56.3 equals 7.6 times sine 9 degrees. Then I need to solve for C. C equals 7.6 sine 9, all that divided by sine 56.3 degrees. Then what do I get here? Put this in the calculator. I got C equals 1.4. C equals 1.4. So this way I was able to solve for the two triangles. Okay. So far what we have been doing we have been using the law of sines to solve the ambiguous case. We can do the same. We can do the same by using law of cosines. But again, I'm not going to focus too much on the law of cosines here, but I'll show an example how we use that. So let's say in triangle ABC, angle A is given 36 degrees, small a is 5, small b is 14. The question, just find angle B. Because if you can find B, you can find the rest so easily using law of sines. Okay, so let me draw a diagram again. This is alpha, or A, is 36 degrees. B is 14. So this should be C. This is the case we have. How many triangles? Is A bigger than or equal to B? Well, wait, do I have to do that here? Do I have to check? You can, and you will find out that there's only one case. one case. But for the meantime, when we try to use law of cosines, just assume this is given already as the full triangle, like so. And what we're gonna do is, I want to find we're gonna find, when we use the law of cosines, we do not have to check if we have one triangle, two triangles, or no triangles. We can just go ahead and find what we need. They want us to find angle B. They want us to find angle B. The first thing I'm gonna do is try to find C here. So we first find the length C. How do you do that? With law of cosines. This is A, so we say A squared equals B squared plus C squared minus 2 times B times C cosine angle alpha. So do you see why I started with law of cosines this way, A squared, because alpha is given. A is 5 squared, B is 14 squared, I don't know C, minus 2, B is 14, I don't know C, cosine 36 degrees. So here we get 25 equals 196 plus C squared minus 28C, and this, let me just keep it as is for now. So now I move everything to one side, so C squared minus, if we put 28 times cosine 36, that gives us 22.65 C, and 196 minus 25, that's 171. So I got a quadratic equation, not easy to factor because of the decimals. So what I'm going to do is use the quadratic formula. The quadratic formula says negative the middle number, so that becomes positive, plus or minus the square root of B squared minus 4 times A times C divided by 2A, so 2 times 1. And let's see what that gives us. This is 22.65 plus or minus the square root. If you put that into the calculator, that gives us negative 170.98, all divided by 2. Notice there is a negative sign under the square root. So that tells us, this tells us C is not a real number. It's going to be complex. It's not a real number. So what that means, no triangle. There's no triangle. So if you happen to go through the requirements, you will find that A is going to be less than H, and that's why there's no triangle. Now, we can look at other examples, or if you like to look at other examples about the use of law of cosines, what's going to happen in this case is that when you do the work, remember, you're not checking if there's a one case, two cases, or no cases. If you happen that the quantity under the square root is 0, then that tells us there's only one triangle. If it happened, you look under the square root and find that it's 0, then that will give us only one value for C, and that means there's only one triangle. What about if that value under the square root is positive? If that value under the square root is positive, that means we're going to have two cases, two triangles. We take, maybe two triangles. It depends on this. So one time we take the positive case, we break it into two cases, one time positive, one time negative. If you end up with two C values, both of them are positive, then that tells us we have two triangles. We're going to have two triangles. Now let's look at an example. This is a word problem in the book, so it's number 26 on page 422. Even if you don't have the book, I'm gonna read it. So we have this hot air balloon is held at a constant altitude by two ropes. So we have let's say the balloon is here, is held to the ground. Okay, one rope is 120 feet long. So this is one rope, 120 feet, and it says it makes angle 65 with the ground. So this angle here is 65. Let's call this A and call this B. That's where the balloon is. The other rope is 115 feet long. So maybe this way. That's 115 feet. Didn't say what angle it makes with the ground. They said, what is the distance? Call this point C. What is the distance between the points on the ground at which the two ropes are closed? So these two, where they tied them, they want this distance. So they want us to find AC basically. So notice there's no mention of solve the triangle. There's no mention of ambiguous cases or non-ambiguous case. There's no mention how many triangles we have. But what we can do here, okay, what we can do is we need to think about solving this. Don't go straight forward and use law of sines or law of cosines. First thing you want to do, okay, drop a height. Let's drop a height. This is H. I'm gonna find, think about this is A. This is C now. I call it C. If you like, I can change this to C and this is B. Doesn't matter. Put this B. So now we need to find AB. If you are used to it this way. So B here. Is A bigger than or equal to B? No, it's not. So the case where it says only one triangle, the fourth case, is not here. It doesn't exist. So that's why we have to find H. H, we used to it, is B sine alpha. So B here is 120 sine 65 degrees. So then H, if I find H, I got about 108.76. Don't forget the feet. That's H. Now, is which one, okay, which condition is met? Notice that this H is less than A, less than B, as you can see. So this tells us two triangles are formed. Oh, two triangles are formed. This means we're going to have two different values for AB. Two different values for AB. Okay? The first one is that, like one of the previous examples, we drew a triangle like this. B is here. B is here. So that's going to be beta 1. Let's call this gamma 1. Okay? Beta 1, gamma 1. But the good thing here, I don't have to find everything. I just want to find AB. Okay, I want to find AB. So let's see what we need to do. Let's look in the first triangle. Can I call this just B1 and B2? This is beta 2. So let's keep that in blue here. So let's look in triangle A, B1, C. A, B1, C. We're going to use law of sines. So sine 65 over A, which is 115, equals sine. See, if I want to find AB1, I can't straight right now because I don't have gamma or gamma 1. So let me find beta 1 first because the side opposite to beta 1 is given. So I'm sure everyone can solve for this by cross multiplying. So then beta, we got 71 degrees. That's beta 1. And just so you know, if you want to find beta 2, that's going to be 180 minus 71. That gives us 109 degrees because we're going to come back to it and use it. So we found beta 1. From here, I'll be able to find gamma 1, which is 180 minus the alpha plus beta in this case. So gamma 1 gave me 44 degrees. Why did I find gamma? Because now I can say sine the gamma 1 over the side I'm looking for, which is AB1, equals sine 65 that was given to us over A itself, which is 115. Cross multiply, and I'm sure everyone can do this. That will give us A1 to be about 88 feet. Don't forget the unit measure. So that's the first case. The next case, we found beta 2. So I can find gamma 2, which is 180 minus the 65 alpha and the beta 2, 109. If you do the work, this will give us 6 degrees, exactly 6 degrees only. And then we can do sine 6 degrees over B equals sine 65 divided by 115. Then solving here by cross multiplying, we get, I'm sure everyone can solve for b. That will give us b in this case, that's AB2. AB2, that gives us exactly 13 feet. So if they ask you to solve for a side, you have to be careful. If it's the SSA case, this means you can get two different measures of the sides depending on how many triangles. If there's no triangle, means no side. If there's one, there's only one side length. If two triangles, means two side lengths. That's what the ambiguous case is all about.